Okay, guys, now we're going to talk about Charles' law. This is another gas law, but the units that we're worried about, or the things we're focused on dealing with a gas, are different. Now we're worried about the volume of a gas and its relationship with temperature. So the difference between Boyle's and Charles is Boyle's is an indirect relationship. As one thing goes up, the other goes down. Charles' law is a direct relationship between volume and temperature, which means if it's a direct relationship, whatever happens to one happens to the other. So if your volume goes up, your temperature goes up. If your volume goes down, your temperature goes down. Let's think of that in terms of a balloon. You've got a balloon filled with helium. It's room temperature, let's say 70 degrees. I stick it in a freezer. Obviously, the temperature is going to drop. What happens to the size of your balloon? The size of the balloon is going to shrink, right? So that means your temperature went down, so the size of your balloon went down. Perfect example. I take my same balloon, I pull it out of the freezer. As it begins to warm up, go back to room temperature, the temperature rises, and the balloon will expand a little bit. The gas molecules will spread out a little bit, so they'll go back to normal size. Then I decide to hold a lighter close to my balloon, right? I hold a lighter underneath my balloon. It's going to get hotter and hotter and hotter until at one point the gas particles spread out so much that what happens? Your balloon busts. So as the temperature increases, the temperature of your gas increases, the volume will go up, spread out, get bigger. Okay? One rule you have to remember, that your temperatures, in order to deal with gas laws, all of your temperatures must be in Kelvin. That's the only way that the math actually works out. So you need to change your Celsius temperatures, add 273, and change those over to Kelvin. Okay? I promise you're going to be given Celsius temperatures in these problems. They always do that. Just to make sure you remember, you got to take Celsius and change them to Kelvin before you start. So let's look at the formula. This is your formula. V1 over T1 equals V2 over T2. And I'm going to give you I'm going to work through a sample problem with you. So let's say you have a gas with a volume of 20 liters, and it's at 35 degrees Celsius. But the temperature outside decreases to 15.3 degrees Celsius. What is the new volume, right? So I said that the hard part about these laws is not the math itself or plugging and chugging and getting your answer. It's discerning which law to use. So you just have to really pay attention to your units. Here you're given a volume, a temperature, and you're asked to find a new volume. So you have to be able to think back. Volume and temperature is Charles' law. The formula is given to you on your reference sheet. I'm going to show you how to find that in class. But you have to remember which one it is. Is it Charles or is it Boyle's, right? So this has to do with volume and temperature. So it's Charles' law. So the first thing I'm going to do is go through my problem, and I'm either going to highlight or I'm going to circle, underline the information that's important. So here is obviously a volume. Typically, the first volume that you're given is your 1, right? Typically, the first volume that you're given and first temperature that you're given, that are your V1 and T1. When you're asked to find something new, that's always going to be your second one, right? The second implies what did it change to? What is it now? So that would be your second ones. So this is going to be your V1's first volume, and it's at 35 degrees Celsius, but there's a problem. This is in Celsius. I need it to be in Kelvin. So I'm going to add 273, and that means it's going to become 318, right? I was wrong. 308. Right? Totally cannot do math in my head at all. So that's your Kelvin temperature. That's the first thing you need to do. Change your Celsiuses over to Kelvin. But then it tells you the temperature outside has now decreased to 15.3 degrees Celsius. We're in Celsius again. I need to change that to Kelvin. Let me just go ahead. 273 plus 15.3. So this one is 288.3 Kelvin. Right? So that's the first thing I have to do. And then it asks me, what is the new volume? So obviously that's important. That's important. New volume is important. That tells me what I'm looking for. So let's start plugging and chugging. We're going to write our formula first, always. And we're going to pick out my first volume. Volume is in liters. That's how I know it's a volume, milliliters or liters. So I put 20 liters. And my first temperature was 308. My new temperature tells me my temperature decreased to 288.3. What is the new volume? So this is obviously what I'm looking for. So I'm going to take you back to like, what, 5th, 6th, 7th grade, where you learn to cross multiply. So I'm going to write it out for you to show you, but some of you can probably totally do that in your head and just plug it in your calculator, and that's fine. But I'm going to write down the math for those that struggle with math. I struggle with math. It's horrible. So when you're cross multiplying, basically what you're doing is you are making an X on your problem. These two go together, and these two go together on opposite side of the equal sign. So I'm just going to write that out. I'm going to start right here. 20 liters. I'm multiplying now. Cross multiplying. I cross over and multiply. 20 times 288.3 equals, and then I'm going to cross multiply these. Making an X, right? I'm crossing over, but I'm putting these together, multiplying. V, my new volume, times 308. Right? And so now I have the same kind of math that I had before. I've got to get my volume unit by himself. He's what I'm trying to solve for. So remember that rule. To get rid of something, you have to do the opposite function. Here you're multiplying, so to get rid of it, I have to divide. Whatever I do on the right side of the equal sign, I must go back and do on the left. It's only fair. So now you guys can multiply that out. Obviously, you do not have my calculator. Let me grab my phone. So I'm going to multiply these two first. 20 times 288.3. I'm going to hit the equal sign, and then I'm just going to go ahead and divide. Divided by 308. And I get a crazy big number. Let me check that out again. 20 times 288.3 divided by 308. Oh yeah, I did something wrong. So my answer is, my new volume is 18.7 liters. Right? My new volume is 18.7 liters. I'm telling you, I never work a problem on a test because I'm so bad at simple math. I'm so bad at simple math that I always work the math out twice. I always work the math out twice just to make sure, especially if I look at my choices and my answer's not there, like somebody messed up. So check your math twice. Let's look and see if that followed the actual law. The actual law says that if your temperature decreases, obviously my temperature decreased, did my volume decrease? Yes, I was at 20, my new volume is 18.7. So yes, it decreased, it followed the law, right? And that's Charles' law.